Hello, everybody. Welcome to another Full Compass, Full Access webinar where we bring you the experts to talk about the subjects that you want to hear about. My name is Jim Ripp. I am the host today. We do have a special guest, Mr. Shawn McLoughlin.
Hey.
Shawn, we haven't seen you in a while. It's good to see you again.
Repeat offender.
Repeat offender and my bearded friend. Yes. So we are going to talk today about WMAS or WMAS.
Or WMAS, yeah.
So it started out as WMAS,
yeah,
right?
there was the little I in there.
Little WIMAS.
Yes,
Now,
yep.
now the industry is taking it as WMAS.
Drop the I. So
Drop the
I
I.
still say WMAS though. Rolls off the tongue a little bit better.
It does. It's easier to roll it off that way. And it's all about the wireless spectrum and some new technologies that has happened in there.
Yeah, so yeah, a lot of it was really just the boiling down of the spectrum. As you know, it's gotten smaller and smaller. So with Shure's ADPSM product that we've got in the back here, this is Shure's first product that has launched with WMAS technology in it. So
perfect. So first, are we going to talk about the?
Yeah, let's talk a little bit about the spectrum and like even what WMAS is, and then we'll get into the ADPSM for the people that haven't seen some of that stuff yet. So
awesome. Let's dig right into it.
Yeah, let's jump in. So if you want to pull up that PowerPoint there, so really a lot of this, like we mentioned, boils down to spectrum. You know, many years ago, 1997. Doesn't seem like it's that long ago, but it's quite a while ago. You know, we actually had quite a bit of spectrum. So 470 to 806 was open for wireless mics and other types of products. Back in 2008, I remember this very well. We had the selling off of some spectrum. So the spectrum got a little bit smaller. It was great selling a lot of wireless back then. But it made everything a little bit tighter. You know, more TV channels were coming in, space was getting smaller. And then this happened again in 2017. If you look, we ended up losing a lot more spectrum. So all of the 700 megahertz went away. So now we're down to 470 to 616 for usable spectrum.
Veterans in the industry went through both of those big changes, and
it was big changes, and a lot of it boils down to it's all because of this wonderful device, the cell phone that we want, computers in our pocket and internet everywhere we go. The telecom communication companies were the people that were buying up a lot of this spectrum, so it's just gotten smaller and smaller, and we hope that we're still going to have spectrum, but coming up with technologies like WMAS to be able to fit in those smaller spaces is really the kind of the key of the game here. So, if we actually, why is this not clicking? If we look here, so this is just a couple scans of some U.S. cities. Since we're close to Chicago, and that's for sure is headquartered at, we'll talk about Chicago. So on this, these are all of the current usable spectrum slots. So each one of those little stripes equals 6 megahertz of bandwidth. And that's the size of a DTV channel. So if you look at Chicago, we only have one little black stripe.
That's usable for us.
That is usable. That's fully wide open. And then there's a little bit, it's a little hard to see at the very, very top of the spectrum. There's a little sliver of black up there. So there's just really not a lot of open space in some of these cities. If you look at New York and Phoenix and Chicago, like some of these, you're running out of bandwidth really quickly, which makes it really hard to use wireless mics. So if you're in the performance industry, hotels, as you know, wireless is used everywhere. So
I'm going to call out right now. We have all the people registered. We've got from all the way from the West Coast to the East Coast, and everything in between. Which is super important for them to know this information.
Yeah.
And we have colleges, we have churches, production houses. Everybody's very interested in this subject. So this is awesome to see this chart, first of all, and lay kind of the groundwork of why.
Yeah, why these technologies are coming out. I mean, just with Shure. Well, actually, I'll bump a slide. So this is kind of where we started. Yeah, Shure's been in the wireless game for a really long time. You can see that very old photo on the back over there called the Vagabond.
The
That was
Vagabond.
the very first Shure wireless system. Off the top of my head, I do not remember exactly what year that came out, but it was there wasn't even color television back then. We'll put it that way. It was a very interesting system. It actually had a piece of wire that went on the ground on the stage, and as long as you were in the wire,
Within the loop. Yeah.
within the loop, you had wireless audio or microphone. So back when like ULXD came out, that was our first foray into digital wireless. So digital wireless over analog, like what we had in the past, is more efficient. You can pack a lot more channels in a smaller space. So as space was starting to be sold off and getting smaller and smaller and smaller, we ended up having to switch to digital. And a good majority of our line is now digital product. So actually, I'm trying to think off the top of my head. Really, the BLX series that we have is the only analog wireless left,
The only one left.
in there. And then we've now kind of switched in and moved into newer technologies that's been digital but narrowband, like Axient Digital and ULXD and things like that, and now also wideband with the ADPSM. So kind of switching into there. So we talked about WMAS of what is WMAS. So it stands for Wireless Multi-Channel Audio System, WMAS. So it's a technology, this was developed in conjunction with the FCC of how to use WMAS. So WMAS isn't necessarily a proprietary technology. Anyone can use WMAS or WMAS. But it's just the guidelines on how to use that. So it's a multi-channel audio in a larger one carrier chunk. So we've got some other slides that kind of show that. But you're going to start seeing more companies coming out with product that uses WMAS technology, and everyone kind of has a little different spin to how they're using it. So it can be used for in-ear monitoring, it can be used for microphones, it can be used, a lot of different products there.
So we could take a quick step back, and Zach, if you could show the two of us here.
Yeah.
How did we get to this point? I know you had mentioned there's a lot of people in the industry that were not protesting. But...
Well, yeah. So, like, Shure, amongst others, were very. I don't want to say not petitioning. I can't think of the word right now, but I guess it was petitioning. But working with the FCC of basically especially when the last chunk was sold off. It's
so lobbying to get
lobbying. That's the word I was looking for. So lobbying to come up with things to help people that are using wireless mics, because
they squished us down to this little area. So
and it's one of those things that I don't think you really truly realize how much wireless is going on at events, or even your church or your band or whatever. I do some stuff with the football games with the UW, and sometimes during a Badger game we're dealing with hundreds of channels of RF, from people on the field to the communications for the cameras to like everything's wireless nowadays. But there's just less and less spectrum, so the need for more efficient technologies and other ways to use the open spectrum is kind of really what drove where some of this technology came from.
So that's good. People at Shure were pushing the part of a bigger, much bigger, I'm sure, other industry experts as well, pushing for this.
A lot of very smart engineers have been pushing for this, way above my brain pay grade. So,
all right, so back to the PowerPoint.
Yeah, so some of the the benefits of WMAS, it kind of unlocks innovation for customers, to kind of use it in the way that they see fit. So like I was saying, you're going to see different WMAS technologies coming out, and people are using them in all different ways. It just really allows for more efficient use of the spectrum, and it's also a scalable architecture. It also it's harmonized with some of the European standards. So this is, kind of aligning for everyone everywhere.
Excellent.
This is just a definition. Take a screenshot. This is what WMAS is. So I'll reread this one. So it's a wireless audio transmission system using digital wideband transmission techniques for microphones and in-ear monitoring system applications and other multi-channel PMSE use, with the ability to support 3 or more audio channels per megahertz. So there's some guidelines with WMAS of what you can do. It has to meet some minimum requirements, has to meet some minimum power, things like that. So you can see the standardization. It's really technology neutral, so it's everyone can use it in their own way. You just have the guidelines of what you can do. It needs to look like this from a carrier standpoint, like that little diagram down there. It's got the the minimum performance and parameters that are all specified. So within that, you can choose how you're going to implement it. So. This is just really getting into the more efficient use. So on the left-hand side here with this diagram, so the little green slivers are narrowband carriers. So like our normal Axient, ULXD, all of these are narrowband carriers. So it's one frequency per transmission. But with RF, you get things called intermods. So as your frequencies are getting closer and closer together, they create little baby intermods. So basically it's the combination of those frequencies combining and creating a false frequency, but it takes up spectrum. So depending on how far you get, that's one of the cool things in Wireless Workbench. You can actually, when you're doing coordination, you can play around with your spacing, and it can show you what the intermods are, because it's all math, on what an intermod is going to be created. But with those 4 channels, like it's showing, all of the red little spikes, those are all intermods, which is taking up space and allowing you not to pack things super close. So moving to a WMAS, you still have those possibilities for intermods, but what we're doing is we're packing a lot of channels into one carrier. So I like to think of it as like a DTV channel. So when we switch to digital television, if you look at a DTV channel, it's a large chunk like that. It has a plateau. There's a little spike at the beginning, which is the carrier, the beginning of the carrier tone and stuff like that. But in there, like if you're scrolling on your TV right now and you look and you go to channel 27, you'll see channel 27-1, -2, -3, -4. So there's 4 TV channels riding in that one 6 megahertz chunk. So we're doing the same type of thing with microphone,
Got it.
Audio
that makes it easier to
transmission.
understand.
So it's just packing those channels. So normally, I think I've got a slide coming up on this. Before, you used to have X amount of spacing on narrowband connectors to switch between, you had to have certain spacing between each thing to not have, I'm losing my train of thought here, to not have intermods and things like that. So there was a minimum spacing between those. Now you can take that minimum spacing, so it's like 200 kilohertz spacing between those 2 frequencies. But now I can take 2 WMAS channels that are both carrying 4 channels of audio and stack them right next to each other with 200 kilohertz spacing. So just using that spectrum more efficiently. So like if you look on the PowerPoint presentation here, so there's a couple different examples of how people are using WMAS. So you can use example 1's using that 6 megahertz chunk, so that TV channel bandwidth, using some of that with a 3 megahertz WMAS transmission, and then also a bunch of small carriers. So they can coexist, not on top of each other, but next to each other in the space. Example 2 shows a large WMAS transmission that's 30 channels in that same 6 megahertz space. And example 3 is WMAS, again, just using a 2 megahertz, for 10 channels. So there's lots of different ways that you can use that technology to be more efficient. So
I'm sure there's advantages and disadvantages.
Yeah.
In using those different.
So like, is WMAS going to be the thing that everything's going to be WMAS? No, it's not. And that's one of the cool things with the Axient Digital PSM. Shure gave us the ability to choose. So I can do analog transmission. I can do narrowband digital transmission. I can do WMAS transmission. It's kind of choose your own adventure based on what else you're using, what else works or is happening in the space that you're in the airspace, I guess I should say. So, you know, single carrier stuff, I mean, with WMAS, the technology, you know, it costs a little bit more to do, you know. So, you know, there's single carrier digital, you know, is cheaper to do. So you are going to find the need for more cost effective product, you know. So not everything's going to be WMAS, you know. The other big thing with narrow band carriers is they can fit in a lot of smaller spaces. So sometimes you have just small slivers of space that you can use. So a narrow band carrier is going to work better in those applications. So like if you're doing a frequency coordination and you do a scan and you've got all your DTV channels, you've got other wireless devices, you might just have tiny little spaces to be able to place your mic. So that's where WMAS isn't going to necessarily work. You know, so you're going to have to go to a narrow band carrier. So, you know, another big question is, you know, can you co-locate WMAS and narrowband, you know, in the same bandwidth? And no, you know, they can't live on top of each other. You know, they're going to be next to each other, just like we had in that slide before. So you can't necessarily stack a whole bunch on top of each other, but using those WMAS, you're just packing everything tighter next to each other because it's that WMAS transmission. I'm just going to throw a couple slides up here. So this really just gets into some of the FCC regulations with WMAS. So it's for licensed and unlicensed users. So you don't have to be licensed with the FCC to use WMAS technology. But again, it needs to have those minimum requirements to be able to be a WMAS transmission. So it has to have at least capable of 3 audio channels per a set bandwidth and all, you know, those different applications. You're also limited on your output of the device. So, and like how hot that signal can be, you know, how much you're transmitting. So you're limited up to 100 milliwatts of bandwidth for larger than the 1 megahertz up to 6 megahertz. So that's, you've got that space that you can be, but you're limited to 100 milliwatts. So, and then you're also your bandwidth limit. So a WMAS channel can't be larger than 6 megahertz, you know, so you're always going to be in there. So again, other people are taking different approaches to WMAS. Shure takes some different approaches, like how we're implementing it with ADPSM versus some of the competition. So we've got some of that in the slides with the Axient Digital as we go over that.
Okay.
But really, you know, kind of key takeaways with WMAS. Again, it's neutral. It's neutral technology that anyone can use for multi-channel audio. Again, there's not really one WMAS protocol, I guess I should say, or WMAS technology. There's different variations of it, and I think you'll see more and more of that.
It's just parameters that you need.
Yeah, it's just the parameters. So Shure's approach really is a scalable approach. You know, there's some things of how the unit can transmit, looking future forward with products, even in here with some of the things that it'll be able to do in the future of how it can transmit. And the way that Shure implemented it, it's a little bit more spectrally efficient than some of the other options out there. There are some people that are implementing WMAS that it's, you know, looking at it very much of that 6 megahertz that you have to be in. I'm going to be a 6 megahertz. So, you know, the disadvantage to that, it's always taking up 6 megahertz. And as you see, some places might not have 6 megahertz, or, you know, at least like Chicago had 1 6 megahertz chunk. So that's where, if you were doing WMAS transmission, that's where you're going to have to live. So all of your narrowband stuff is going to have to live in other spaces. So, you know, there are some advantages and, you know, and disadvantages to WMAS in there. The other cool thing is, you know, WMAS is regulated. It's allowed, you know, USA, Europe, EU, Canada, Mexico, you know, it's a united standard, I guess I should say, for transmission. So a lot of the products, we sell globally, all around the world. So they have to be able to comply and be able to be used for that. So really, when Shure, this is something that's specifically talking with about ADPSM, since this is our first product with it. The way that Shure implemented WMAS, it gives us the ability to have more channels per frequency, so it's give us higher channel counts. It's backwards compatible with the way that we're implementing ADPSM is, so you're not just a WMAS product. Like I mentioned before, you can actually switch to digital narrowband. You can switch to analog, just like our PSM 1000. It's compatible with that. And ADPSM allows us to have a lot more channels in rack density. We're shrinking the size of the racks that you need. So. Also ensures implementation of WMAS. The way that we're approaching interference, it can check out and interfere with just a small portion of that WMAS channel versus taking out the whole that whole block and losing multiple channels of audio. So we've got the ability to be a little bit more reliable in our implementation of
because you're not doing the whole block.
Correct, because you're not doing the whole block, so you've got multiple channels within that block, so you're able to get around some interference a little bit better. There's also the shared power. We kind of touched on this. There's power requirements for that WMAS transmission. You're limited on how much power on that transmission. So in
carrier is
the carrier, I guess, yeah. Because it's a carrier with multiple channels of audio on the carrier. So that's something to think about, and that's one really cool thing when we get into looking at the ADPSM and the choose your own adventure, I guess I'd say, of how do I want to operate this? Do I want to be in analog? Do I want to be in WMAS? Do I want to be in digital? Do I want, all those different questions? But there's actually a guided process on the unit that steps you through and says, here's what you're dealing with power output and everything. So in this example, like I'm limited to that 100 milliwatts in that transmission. So if I'm transmitting a WMAS, one carrier that's 4 channels within that carrier, I'm limited to 25 milliwatts per channel. Example B, if I'm cramming 8 channels in that WMAS, which is totally doable, but you're bringing your overall down to 12.5 milliwatts per channel. Again, what does that mean in reality of what I can cover and how I can cover that? A lot of that depends on the environment, what else is going on and what the RF noise floor is and things like that. Also when you're getting into narrowband and wideband, perfect example, on here is if you're looking, so this is talking about, a 6 megahertz chunk there. So it's saying, Axient Digital, our regular Axient Digital, like we're talking on now with our lapels, I can fit 17 channels in that 6 megahertz. With PSM, being analog and the intermods and everything that were in there, it was 9. I could get 9 channels in that same 6 megahertz. But when we're going up to using two blocks, it's not necessarily linear, like especially with the analog. Like you'll notice that PSM 1000, even though I'm in 2 6 megahertz or 12 megahertz chunk, I can only get 14 channels because of the intermods and everything that are in there. So using WMAS is going to allow us to have a lot more options there.
Nice.
Looks like there is a question since I've been rambling.
Yeah. What's the other manufacturers are agreeing with the WMAS requirements?
What other manufacturers are agreeing with?
Agreeing.
Okay, so yeah, I guess what you're asking, like what other manufacturers? So, like right now, the other one that I know off the top of my head is Sennheiser has announced some products using WMAS. That's the most notable one that I've heard besides Shure's product line. But I do know that there are other people looking at it in our.
And I'm sure that down the line, more and more people will be catching up and starting to implement that.
Yep.
Okay.
So getting into like when WMAS would work versus single carriers. So like this is just showing two different scans. I can't remember where this was. Oh, Phoenix. It says it right in the middle. So this is just an example of, hey, I need 20 channels of IEM in-ear monitors in Phoenix, Arizona. So looking at having Workbench calculate this, using PSM 1000, our analog product, which used to be our top of the line for touring, based on that space and the need, Workbench is only calculating 14 channels out of those 20. So you're only going to be able to get 14 channels on there. There might be some tricks that you can play to maybe squeeze some more in there, depending. But a lot of times, it's like, okay, now I just need to cut people's ears or share channels or do things like that. But now going to that same bandwidth and using WMAS, I can actually use 5 different carriers, and all of those carriers could be having 4 channels on them. So I'm able to pack a lot more channels into that space to be able to accommodate those very narrow spaces in the market there. So it's a really cool technology. I just got my demo unit, so I've been starting to play around with it and see what the power really means. Because we're going from analog to digital, so your power outputs and everything are kind of totally different. What you're used to. It was kind of fun. We were actually doing a training here at Full Compass yesterday. 2 days ago?
Yeah.
It was yesterday. No, it was
2 days ago.
It was 2 days ago. Whatever. But I had the PSM set up, and we had the directional antenna, the helical here. And I was able to literally walk around the whole building, not anywhere in view of the transmit or the antenna, and still had great coverage. And we were using that in WMAS mode, so nice. I wasn't even using the single carrier, narrow band where we can get more output. So it's kind of a cool thing. So
yes, any questions coming in? Feel free to type those questions anytime. We'll do our best to answer them. So again, Shawn, there's different ways to use WMAS. Again, we're calling it WMAS.
Yeah, I like WMAS.
WMAS is more difficult to say. WMAS. And those different ways to use it. And there's so many different chunks of our industry, whether it be theater or production houses, rock shows, colleges, that each one can use it in a different way. So it's important to keep in mind what you're looking to achieve.
Yep. Before
making that choice.
Yeah, definitely. It's like looking at how you are, what your spectrum is. I mean, this is one of the conversations that I always like to have with salespeople and end users is, a lot of people are like, I need a wireless mic, or I need 4 wireless mics. But a lot of it is like starting to think of like, okay, you may want 4 wireless mics now, but what do you want in the future? Like you got to be a lot more, you got to be a lot more forward thinking now of where you ultimately want to go. To choose your technology, because even within, just looking at digital wireless, like we've got our Axient system that I said was, 17 channels per 6 megahertz. We also have our SLXD, which isn't quite as efficient spectrally. You get about 12 channels in that same 6 megahertz. So that's like part of your choice is, a lot of times people are very budget conscious. But now with wireless, because of the lack of spectrum and everything, you have to be a little bit more forward thinking of where do I want to go, what might be creeping up, what spectrum am I working with, to choose the technology that you're using. And that was, kind of one of the reasons why, Shure came out with ADPSM was there is a demand. I wouldn't say every touring band member uses in-ears, but it is pretty common nowadays that people are using in-ears plus a whole bunch of wireless. People like to have the freedom of wireless.
If you're touring around or you jump out of the United States and tour in Europe, it's important to know.
Yeah.
And beforehand.
Yeah, you got to. It's kind of some different regulations over there, and different RF approaches. Some of the TV channels are wider over there, and there's a lot to learn with RF. So
with this new WMAS.
Yep.
it's great that the FCC has kind of loosened the belt restraint that they had on everything a little bit, right? So it opens up for some more technologies on the manufacturer's end to push forward, and one of them being what we got right here.
Yeah.
So
we've done a few things with you guys on the Axient Digital PSM, so some of this might be review for people, but you know, it has now launched and is shipping and starting to make its way out on tours. Full Compass actually has it in stock, so that's really good. So in stock, ready to rock. Looks like we got another question, so let's pull that up.
I know you mentioned this, but to be clear, can you use both WMAS and narrowband at the same time in different frequencies or not?
Yes. So, like I'll talk about ADPSM. With this product, because you can choose narrowband or wideband, you are choosing it for the whole unit, basically. So I'm going to say my quad is either going to be in a narrowband mode or it's going to be in a wideband mode. I got two quads here, so I could have this one operating in narrowband and this one operating in wideband. Yes, they're going to be on different frequencies, but a WMAS transmission, let's say my four fingers are my four narrow carriers and my closed hand, looking weird, but my closed hand here is my WMAS transmission. So they can be next to each other in open bandwidth and cohabitate, I guess is
You just can't.
Yeah, you just can't be on top of each other, just like any other RF signals. But yeah, you can't operate in spaces. So I actually just did a design for a TV station that was looking at upgrading, and they're moving to Axient Digital PSM for their on broadcast. They also call them IFBs versus IEMs for their IFBs, and then also Axient Digital for their microphones. And in that one, based on where they were in the country and looking at everything, we determined that actually there would be a benefit to run the in-ears or the IFBs in WMAS mode, but all their mics are still in narrowband transmission. So like they're cohabitating, and choosing where we were putting them in the spectrum, you know, allowed us to kind of cram more things in there. And they were actually choosing the technology because they're in an area where they're close to the water. So in the summer, they get a lot of ship-to-shore radios and things. So the TV station's actually getting stomped on a lot from their wireless mics because a lot of people don't know what they're actually doing. So, you know, that's one of the reasons why they chose the Axient Digital, because of that ability to move around and avoid frequency, or if it does actually have interference, it can just automatically move to a new channel. So, but yeah, they can cohabitate near each other. Near each other. From the Shure technologies, you are choosing it. The device is one or the other. I'm in a WMAS or I'm in a single carrier mode.
Got it.
So,
excellent question.
But yeah, let's dive into, you know, part of like PSM and why Shure developed the ADPSM. So, you know, a lot of what it was, you know, when Shure started asking people, you know, a lot of, you know, touring engineers and monitor engineers, what were they looking for? These were a lot of the things, you know, Axient Digital has been the mainstay for a lot of touring. So a lot of people wanted, you know, the quality of an Axient Digital system with their in-ears. A lot of people also did want the ability to have digital inputs, which was one of the things that we hadn't had. Encryption has become more and more requested for in-ears. Ooh, it looks like we got a lot of questions coming in. So let's stop. Let's answer questions.
All right,
let's do that.
Can you see that?
I cannot mention.
If you could make that bigger, Zach, that would be fantastic. It just
we're getting old. Right? Jim and I are getting old.
All right, you mentioned for each WMAS block, 3 audio channels are required to be supported. Is that true?
It's a minimum of 3.
Minimum of 3. What is the smallest WMAS package? How is it packaged? And then it says half rack, question mark.
Okay, so this like the smallest with Shure is, well, I'll get into this with the Axient Digital because I've got some slides on this. But our WMAS transmission on a quad is an 800 kilohertz chunk, an 800 kilohertz carrier for 4 channels. Our dual, which I don't actually have here, actually is a smaller WMAS packet because of the way that it's a dual channel system. So you've actually got a 400 kilohertz carrier for that.
Is it still a full rack space?
It is still full rack space. Everything that Shure is doing is full rack space. There are some things that are coming in the future with ADPSM for expansion and things like that from a channel count. So
listen up to that. You're getting
stay tuned.
Hint.
Yes.
All right. What's the other question? Can you discuss time frame for more information or having multiple WMAS carriers in one frame? Price, details, anything about?
Is this time frame for more information on taking or having multiple WMAS carriers in one frame? It's coming. Stay tuned. That's about as best as I can do. You know, we've got some stuff coming with you know, future firmware updates to the system that will allow you to expand your channel count. But stay tuned.
Okay. A question from Jim here: is the Shure Spectrum Manager able to deploy both narrowband and WMAS frequencies?
Yes. The Spectrum Manager, which I don't actually have in the rack, will be able to handle the management of WMAS carriers and narrowband carriers.
Good question.
So you will be able to do both.
And another question here from Mr. Anonymous: are the latency differences between narrow and WMAS?
No. So with ADPSM, there is not a latency difference between WMAS or
Whichever
a
one you're
narrowband
using.
carrier. Now, there is a difference in latency if you're in analog transmission mode or digital transmission mode.
Definitely.
With digital, you have a little bit more latency that you are dealing with. So there is some difference, and I actually have a slide showing that.
Okay.
Off the top of my head, I can't remember. I believe it is 2.9. Don't quote me on that until we get to the slide.
Until we get there. All right. We can jump back into that.
So, yeah, but yeah. So you know, some of the things that people were looking for, low latency. There we go. Perfect lead in. People wanted low latency, but digital audio. Wide tuning was a huge thing when Axient Digital microphones came out. They were wideband units. So it was the full UHF spectrum, which a lot of touring people really liked, as you were able to go anywhere in the United States and I can tune a frequency. Whereas,
even Chicago.
Our previous systems, a lot of things were locked into bands. It was the G band, the J band, the H band, and that changed based on the unit. But the crummy thing, we see this a lot with a lot of bands like, oh, I'm starting in Madison, Wisconsin, so you're like thinking in your Madison, Wisconsin mind of what your frequencies are, and then you go on the road and that might not be available. That bandwidth might not be available. So it's again, that's one of the advantages of going to a wideband option there, and especially now it was with the repack of all the TV stations with the last auction. Things kind of flip-flopped because they moved TV stations, because all the TV stations that were up here had to move down here. And then they repacked everything and moved it around. So in like Wisconsin and Illinois, G band used to be the best. But after the repack, J actually became more favorable because of where TV stations moved to. So that's one of the advantages of having wideband. Spectral efficiency was another big thing that people wanted, was to do that. I'm going to skip some of these slides, but with Shure Axient Digital PSM or ADPSM, so there's some software coming. So like right now, what is shipping is what we're calling Release 1. So we'll get into all of this, but the ShowLink remote control capabilities of the packs, the encryption, being able to encrypt the audio that's going back if you're in a sensitive thing, network sync, which is a really cool thing, spatial diversity, all the Spark combiners and the Q mode, the wideband transmission, which is that WMAS. Firmware updates over the air, analog FM mode. That is what is shipping currently right now. A little bit later this year, we will be seeing, release 2, which is just going to be a firmware update to be able to do stuff. So some of the things that it's going to be able to do is the interference mitigation and avoidance. So this is where, like what we've got on Axient digital microphones right now, of if I take a hit, I'll be able to move my frequency around. I'll also be able to do frequency diversity point to point, which I really dig because we've lost this when we switched to digital microphones, but analog wireless PSMs. We used to be able to do what was called point to point mode, where you could take a PSM transmitter and a microphone receiver. Back in the day, it used to be very common to do this with PSM 1000 and UHF-R. And we were able to do a point-to-point for larger audio transmission, a delay tower. You guys actually used something similar this weekend for an event, or last weekend, 2 weekends ago.
All last week. Yeah,
it was last week. You were doing an event where it was actually on the ice. It was the kite ice.
It's the
Frozen
Lakes Festival.
Yeah, Frozen Lakes Festival.
But it was the World Championship of the, and I don't know the technical term.
They're like the boats with
the parasail, the kite guys that race on the ice. But there was also, I believe, the DN Ice Boat Nationals Championship that was happening. But what we had solved the problem through that. They wanted to announce things from the shore, and out in the middle of the frozen lake, they wanted to have an announcer out there as well. So we had 2 separate audio systems wirelessly linked to where if this announcer talked, they could hear back at shore. If the shore announcer talked, they could hear out on the lake.
So we were doing that with
flawless
PSM 1000, just using the packs. But now we'll be able to do that point to point, that you can actually, get the ability of nice having rack gear versus using a pack and external antennas and things like that.
Nice.
So that'll all be coming in that future mode. And then the other one is the channel expansion, like we had talked, the ability of expanding this out. If you look at the back plane, which we'll see here later, a quad can become 8 channels, with some licensing and expansion there. So, from a component wise, we can go through this. So with the Axient Digital, there's the ADTQ, which is the quad transmitter, the Axient Digital Transmitter Q for quad, the ADTQ. These are very hard to roll. They roll off the tongue. But this is a quad transmitter. It can be 4 narrowband or currently right now a WMAS transmission. So 1 WMAS transmission that has my 4 channels in there, or I can do 4 individual channels. This supports spatial diversity. I will get into spatial diversity a little bit later. It's actually a really cool thing. It says it in these slides like a million different times before we get to it. So big thing though is you can go analog, you can go AES, you can go Dante into it. You also have internal antenna combining, which has been something that's really cool. Previously, all of our PSMs in the past have had an individual output. You would have to go to an antenna combiner. So now you can actually do internal antenna combining and just use a single output on the back of the unit. So it'll give you a lot more rack density.
Quick question of myself, and we also have a question in the thing. Do you for WMAS, do you need a different antenna?
Nope, same antenna.
Same antenna.
Same antenna. Yeah, everything is the same. So,
all right.
For upcoming point-to-point applications, what kind of line of sight range can be expected? Rough, of course. I like that. That totally depends. It's going to depend on your environment, but several hundred feet, potentially even more. I actually did a thing with Axient Digital Wireless. I was doing an event up in Devil's Lake. It was the NCAA championships for rowing, and we did a similar thing where the announcer and the referees are on a boat that's out with the other people that are rowing, that are competing, and we needed to get that audio back to shore. So we were actually, it was a little over a mile away. You know, we were using helical antennas in both locations to get as much forward gain, but I was doing that, you know, back then. So, you know, potentially the point to point, you're going to be able to do very long runs. A lot of it gets into antenna placement, what type of antenna you're using,
The
what kind of forward
environment,
gain, the environment,
obstruction, anything.
but easily several hundreds of feet.
Hundreds of feet.
You know, you'll be able to expect out of that. So,
Okay. Good question.
So back to the, oh, we got another question. The questions keep on rolling in. I like this. I like questions.
Battery life, same as WMAS versus narrow?
Yeah, same. Yep. So you're not getting any difference on the batteries there. So no disadvantage there.
Thank you, Martin, for that question. Good questions coming in.
So back to the quad transmitter.
Yeah, we're
I know we're getting close.
We're getting close. So
we'll hammer through some of this. So there are a couple different spectral variants here. So there's G57 is like what we were talking about, the UHF spectrum that you're going to be seeing. K54 is actually just some narrow band stuff that is licensed that you'll typically see in broadcasts. And then X55 is actually going to be up in the 900 megahertz. So outside of that UHF, so that's very common for broadcast companies to be using up in that spectrum there. So
X55 rolls off nicely.
X55, yes.
We're using the X55s.
So you'll notice on there's a little 4-port switch. I got my 8 analog inputs. I can do 1/4 inch. I can do XLR. I can also do those Dante inputs. And
4 stereo channels.
Yep, 4 stereo channels or 8 mono I could do. Dual, or the dual, it's just 2 channels. It has half the connections on the back, so pretty standard there.
Not a half rack, full rack.
Yep, both are full rack. This one shows the DC power option. So if you're in broadcast, you can do DC power, which is very common for backup because you can do DC battery power.
Is that the 5-pin?
That's the 5-pin XLR. Or actually, yeah. That's over. Actually, a 4-pin. That's on there. The pack is, there's one pack, the Axient Digital, the ADXR. So it is an Axient Digital with the frequency capabilities and the two-way communications with ShowLink. It is true diversity, and what that means is there's actually 2 different radios in this pack. So there's a radio for channel A and there's a radio for channel B. So this, what that advantage gives you is if I lose transmission or I drop a packet, you know, from transmission on A, I'll have it on B, and that all funnels together. So spatial diversity, which I'll show you here, and frequency diversity we'll get into a little bit later because that's coming up. But again, these are also A, B, and C tuning, so those match up with the G57, K54, all of that. All of these have ShowLink capabilities. So ShowLink is this little box up here, or AD610. That is the two-way communication. So this talks back from the rack to the pack. So this allows you to do different things like change volume, EQ, change the frequency on the pack, change the power, you know, lock out things. You've got a whole lot of control. I can also monitor my battery life back in like Workbench, so this can report back via ShowLink showing
wirelessly.
Correct. Yeah. So like if I have wireless Workbench, yeah, correct. Well, it would be
combination.
Yes, it's combination. So Workbench would be tied in to the network, but this is wirelessly communicating back through the ShowLink. Another cool thing is you can actually do network communication through the ShowLink. So no need to, after you've got a channel synced to a unit, you don't actually have to use the IR sync to push frequencies and do things like that. That can all be done over ShowLink. Nice. Another big thing which has not happened before is the ability to do over-the-air updates. If you have ever updated wireless microphones, you have to use the little IR window that's on the back and hold it on the unit for about sometimes 30 seconds to a minute, depending on what's going on, to update that.
We got a deep question here that I don't know. All right, for those of us who hold Part 74 licenses, what amendments are needed to cover the WMAS system in addition to the NFM?
Ooh,
We are you stumped.
that
I'm
one
stumped.
is above my head. So if you hold the Part 74, what amendments? That is a good question. We will have to get back to you on that one.
Frederick, if you could do
It's above my pay grade.
if you do a favor and email that question, we have it here recorded, but email it to fullaccess@fullcompass.com, and we will dig deep in that one. Try and find somebody that can answer
we'll work
that
with
for you.
the
Absolutely.
engineers at Shure and
So
get that answer for you.
fullaccess@fullcompass.com.
Oh, look, there it goes.
I
It's
can
right
point
below.
to it right
Yeah,
there.
it's right below. So being able to do over-the-air updates is really cool. Like I just had to with the current firmware. I actually had to do an IR sync for all of my 10 packs in my demo kit yesterday, and it took a little bit. But now I can actually just turn on all the packs, hit firmware update, and it does it all wirelessly. So looks like we had another question. Oh, thanks, Frederick.
You're
Thumbs
welcome.
up. Kind of blazing through some of this. So on the ADXRs, there was some optimization to, especially the headphone amplifier that's in there. It's meant to work with a lot of different headphones, earphones. We're getting into a lot of different impedances now with all these triple, quad, 24 driver in-ears.
Exactly.
This has been really cool. A lot of people really love the audio quality that's coming out of the new systems. I've done some demos between ADPSM and like PSM 1000, and people are like, it's night and day. So, is it
possible to have multiple receivers on a single WMAS channel for duplicate of the audio channel? One transmission of audio to multiple packs.
Not currently. That's getting into the frequency diversity that's going to be coming later on. So we can do this similarly. It's not on the same frequency. We have done this on our Axient digital transmitters. Our ADX has a frequency diversity. So it's actually broadcasting on two separate frequencies, but your pack is receiving both of those frequencies at the same time. So it's basically redundant RF. So they're not on the same frequency, they're on separate frequencies, but if you take a hit on one, you've got the same audio and transmission on that backup frequency. So that's something that is coming with a future firmware update.
Got it. Blazing forward.
Blazing forward. The knob. I like talking about the knob. The knob is actually really cool if you're a musician and have ever had to feel the knob. They did a real nice tactile knurled knob, and it has nice stepped position. So it's got a good feel.
But it only goes to 10.
It only goes to 10. We joked. We should have said that should have gone to 11. A little Spinal Tap joke there. So one other kind of cool thing is they put the IR window on the back of this unit. Previously, a lot of our packs have had the wireless either under the door or on the front. So when you were holding it to sync it, you could never see what was on the display. So they put it on the back now, so I can actually hold it up to the display and see what's going on.
Sync success.
Sync there.
Perfect.
We got another question.
Will the ADXR report an unplugged IEM via show link if the IEMs are unplugged?
I need to double check on that. Currently, there's some things that will be coming in firmware that will allow you to see some more of the headphone information and even change volume and stuff like that. So I don't know if that will report the unplug, because it would be looking at impedance change on there. But I know there are some things that are coming with ShowLink.
So the answer currently no.
Currently no, but potentially
Possibly.
in the future. I would have to double check on that. So again, email that one and we can actually dig in to see if I can get that answer for you.
fullaccess@fullcompass.com.
Another cool thing about the packs here.
Yes.
Q mode. So if you're a monitor engineer, you need the ability to monitor all of your channels. So this pack, you've actually got the ability to upload what's called Q mode, and
Do you have a
have
slide on that one?
up to 64. Yeah, there's a slide on that one. 64 channels of audio in a Q mode here. So when you've got a pack set up, you can see the cue list down there. It's labeled lead guitar, guitar. So you can basically be a monitor engineer and just use the arrows to go down and step through all of the different channels to be able to monitor. And encryption is something that's actually supported on that, which is something we haven't had before. Another cool thing is once you build that Q pack, you can actually do an IR sync to another pack and transfer that Q list over. So if you've got maybe a guitar tech or somebody else that needs to hear about a bunch of channels, you can do that.
So currently, yes, I think this is Paul. He's asking, did you say that you can't have 2 or more receiver packs receive the same transmission signal?
Oh, just receiving. Yes, you can have multiple packs receiving the same transmission. Just like when I do my demos, I'm just sending audio to one channel, but I might have 5 packs synced with that channel. So you can have multiple packs receiving, yes, even on WMAS transmission. So yeah, you can have, like, if you're a band, and let's say I wanted to get 8 channels and I'm doing 8 mono signals. This has what's called a mix mode where you can listen to the left or the right channel, but it comes out of both ears. But each of those channels is on a different frequency. So you can have multiple packs and then you're just choosing what you want to listen to.
Just the same mix to all multiple packs.
Yeah. So that if you, especially like this comes in handy with guitar techs or pyro or people that are on stage on tour, is there's a lot of people that need to listen to one channel, but I need multiple packs doing that. So yes, that is fully capable. So just to mention on the ADXRs, these are rechargeable batteries only. It comes with the batteries, so you don't have to buy them. It comes with 2 batteries per pack. So you've got about a 4 to 5 hour battery life on a charge there. So depending on what mode you're in, there's a lot of variables with that. What headphones are you driving? How loud do you have? What power transmission? All of that. It does also have charging contacts on the back here, so you can actually put it into a dock. On my unit here, I've got the SBRC, which is the rack mount charger, so I'm charging there, but you do have the dock that's pictured there that you can just take it off, plug it in, and charge, and go from there. So I did want to touch on a couple accessories since I know we're running out of time here. But antenna combining. I mentioned we've got internal antenna combining. There's the positives and negatives of internal antenna combining based on your power outputs and signal loss and other things like that, just like with any external. But we also have external antenna combiners that are new to the ADPSM. Old ones don't work on the old PSM antenna combiners, won't work with this system due to the output transmission and the signals it'll cook them. But we do have a new 8-port antenna combiner that allows you to set it up in either 2 4-to-1 modes or an 8-to-1. But what's really cool about this is this has what's called automatic transmission makeup gain. So through the BNCs, it actually talks to the unit and sees what transmission mode you are in and how much signal loss. So if you're doing internal combining, there's going to be X amount of signal loss every time you combine a signal. So it's the transmitter is going to talk to the antenna combiner saying, hey, I'm in this mode and I'm going to be losing maybe, let's say, 4 dB or 6 dB of signal. And the antenna combiner can tell the transmitter to do makeup gain to overcome that loss of that antenna combining that's going on. So it just does that all through the BNCs, which is really cool.
How long does it take to charge?
That is a good question. I believe from 0, like fully flat to 100%, I believe is about a 3-hour charge. Generally with most of the Shure batteries, just like our other products, if you were dead and you put it on the charger for about 15 minutes, you'll get approximately an hour-ish of transmit time. So if something was totally flat, you've got that.
It's rare that you do that.
It is rare that you do that, but it can happen.
Yes.
I know we're running out of time, so let's. I see another question come in, but I think that's really, from the component wise, that's like kind of all the nuts and bolts, transmitters, receivers. We've got a few other things that I can talk about on the different transmissions, but I know we're running out of time. So
Any built-in antenna combining on dual channel units?
yes, there is antenna combining on the dual channel units also.
Okay. And what do we got in this slide?
So this is really just talking about the transmission modes. I mentioned this earlier. We've got our WMAS all the way on the right there. That's that WMAS transmission where I'm putting 4 channels in that 800 kilohertz carrier. The digital transmission mode, which is our narrow band, which is going to be our single carrier, so 4 different carriers. Those are going to be 200 kilohertz spacing. And then we also have analog mode. So if you wanted to work with your old PSM 1000 packs, you can actually pair those up with this transmitter and get the advantage of being able to do Dante in, but analog transmission to your packs.
Oh, that's fantastic.
So there's a lot of different things. We did talk about latency. 2.9 milliseconds in digital mode, whether that's Dante or AES, it's 2.9 milliseconds. And then 1.29 in analog mode. So very low latency there.
Yes.
You do have some trade-offs when you are in analog mode. Obviously, you get quicker, less latency, but you lose some of the spatial diversity and frequency diversity and other things like that, plus also the spectral efficiency.
So any chance down the road that these batteries could have a longer life?
Don't really know on that one. That is a good question. Don't know if it would get longer than that. Based on what's in there, but I have seen things happen with firmwares as things get tightened up. Sometimes we can get a little bit longer battery life.
Hey, good question, Jonathan. Can we get this PowerPoint that I could send out to?
Yeah, I believe so. Yes, I believe so.
You better check.
I think so. I got to check with the.
So we'll check
the Mucky Mucks, but yes.
If Jonathan, is it Jonathan? Was it Jonathan? Yeah. If we can, then you'll see it in when we send out the links to the recording of it. If we can't, I'll put a note in there that says.
Yeah, the recording will be available. That'll actually be listed on the Gearcast site, the YouTube.
Correct. So you'll be able to watch it that way, but to have that, yeah.
Where can we access the recording? Like we said, you'll get an email to the link to it, and then it'll also be on the website.
Correct. It'll be on our Gearcast channel, which is on our website. So you just go to our website at the top of the page. It says Gearcast. You follow that. Also, just go on YouTube and search Full Compass. Our Full Compass channel will have that as well. And then I believe we do post it out on LinkedIn. So subscribe to all of those, and then you will see it eventually.
So I know we're short. Can I have 5 more minutes?
Yeah.
All right.
Can we have multiple TX antennas? Can you talk about
spatial diversity? Yes, that's what I was gonna. That's what I was gonna squeak in here. So thank you for that. So we're going to talk about spatial diversity. So previously with PSMs, so you have one channel that's transmitting. Just like your wireless mic, I have a single microphone transmitting back to my receiver. This has one transmission to my body pack. If you put up multiple antennas before with an analog system, you just can't. You would get a lot of interference. Your pack would drop out because it doesn't know what frequency it's listening to. So Shure on ADPSM has given you the ability to do spatial diversity.
Mm-hmm.
So there are some potential trade-offs with spatial diversity in that you potentially can lose channel count on the unit depending on which mode you're in. So this gets into that crazy choose your own adventure. You are basically borrowing the radios that are in there. So on my quad unit, I've got 8 radios that are in here, 1 for each channel. So in spatial diversity, as you can see in the little diagram up there, I lose, if I'm in narrow band mode, I will lose 2 channels. So my 4-channel quad will become just 2 channels of audio. But what that does is it actually allows you to broadcast on 2 different antennas. So I've got a cool thing here. So we've got the blue antenna and the red antenna. There's some magic going on how they do this, but I like the easiest way of putting this out there, is on the blue antenna, there's a little bit of header on the transmission that says, hey, I'm the blue antenna. And then there's a little header on the data that's on the red one saying, I'm the red antenna. So the pack is intelligently able to listen and say, hey, this is the blue data, this is the red data. I know they're the same audio and the same frequency, but if I'm getting a dropout from one area based on multipath and all that stuff, I'm picking up that data from the other antenna that's being transmitted. So it just increases your coverage. So this is good in a situation like this, where you just need to cover a stage better. Especially when you are starting to use helical antennas because you're wanting that forward gain and the RF, you're getting narrower on your transmission. So you have to be a lot more strategic on where you're placing antennas to do that. But spatial diversity allows you to have, this one is zone reinforcement. You can also do this as multi-zone coverage with the same pack. So we were doing this on that TV station I was talking about. They want to be able to mic up talent, and they want to be able to go from one studio to the other studio without having to take off their packs and switch it. So we're using spatial diversity to be able to cover multiple zones that are actually 2 different studios and 2 different sections of the building.
Interesting.
So they'll be able to walk with that one pack. So you can use it as multi-zone coverage. And then this just gets into multi-zone coverage using some of our 2-channel splitters, which I didn't get into. But this would be kind of multiple zones. Like think of a large festival that has 2 side-by-side stages. You've got the ability to do that. Or you can get into extending coverage over parade routes. I don't know why somebody's using like photos from like 1930s parades, but
I was gonna say.
We've got that. So you could do distributed antennas, across an area to get longer coverage over multiple areas. So spatial diversity is really cool. I had a buddy of mine who was going out with a rock band. They had a stage, it was an arena tour. They had a large stage, and then they had a thrust stage in front. So they had an antenna out on that little thrust stage, and they had an antenna covering the normal portion of the stage. So when they came out there, they were able to get in there. And that was a really positive feedback. That was the first show that one of my customers used it on. And the lead singer literally came up to my friend who was doing RF and gave him a hug and was like, this is the best my in-ears have ever sounded. I didn't have any dropout issues. The audio quality was amazing. And that was one thing that they had struggled on their last tour because they were using analog wireless. They were using PSM 1000, but so many of the spaces, there wasn't the bandwidth available. So there were dropout issues and things that you had to deal with. So it's cool to see when an artist, gives the RF tech a hug saying,
Right.
Yeah, good job, great product. So got one other question or multiples.
One more, this is the last one. Then we're out. What is the maximum distance from unit to antenna? We talked about that, didn't we?
That is totally dependent on the environment. When I was saying the full compass building, how big is this building? Several 100,000 square feet.
Yes.
So I was doing the training the other day in the room on the other side of the building. I had this helical antenna set up pointing in one direction, and I was able to walk all the way across the building into the large studio, which I'm overlooking over here.
Multiple walls in between.
Multiple walls in between, and be able to wander around the whole building without any dropouts there. So again, that's a loaded question. It depends on your environment, depends on your antenna placement, depends on what your RF output that you've got the unit set to. But my buddy, again, who was on that tour, did an arena. And it was a decent size. It was a basketball arena in Ohio, and he was able to walk the whole arena with the antennas being placed on stage, focused on covering the stage, and didn't have any dropouts during testing. So you've got large coverage areas. Actually, just recently at the Super Bowl that happened this last weekend, they were using ADPSM on the talent all over the field. So
there you go. At the Super Bowl.
At the Super Bowl.
So that's everything, Shawn.
That was everything. That flew by, and we went 10 minutes over. So.
Boy, talk about information packed. So again, you will have the recording. You can go back and watch again. If Shawn's deck here, the PowerPoint deck, is available, I will send that out as well.
Yep.
But check into that for us.
Yeah, and if you've got any other additional questions, like Jim said, just email those out, and we'll be happy to
see if my magic.
Is the magic? Ah, there we go.
Full access at fullcompass.com.
But yeah, email us if you've got any additional questions, and also if you've got questions, reach out to your salesperson, and they can put you in contact with me. I am more than happy to spin the little propeller on my propeller head and talk gear. That's what I love about doing this job. So,
Shawn, it was a pleasure, man.
Yeah.
Lots of information there, and there's one super in-deep question we still need to address.
Yes.
To figure that out. I can't remember.
There is Part 74 licenses.
Yes. Yes, that question, we'll get to that. Thank you, everybody, for watching. We will see you again on the next Full Compass, Full Access webinar. Have a great day, everybody.
One more question. One more question.
One more question?
Can we sneak it in?
Can we get it?
Oh,
Thank you.
All right, thank you.
You're welcome.